Welcome to today's Explainer. I'm absolutely thrilled to dive into this one with you because, well, we are tackling what is easily one of the most mind-bending, reality-altering concepts in all of modern physics. Look around you for a second. Imagine that absolutely everything you see, every single star up in the night sky, every galaxy we have ever mapped, and literally every tiny atom vibrating in your own body right now, is not actually the whole story. What if everything we know is just one nested layer of a much larger existence? So let's just jump right in and ask the big question. What if our entire universe is really just the inside of a bubble? And I'm not talking about a soap bubble here. We're talking about a cosmic bubble formed from something called a decaying vacuum energy. I know, it sounds totally like science fiction, right? But the wild thing is, this idea pops right out of the actual math of quantum field theory. All right, Section 1, the false vacuum explained, understanding quantum energy states. Okay, to really wrap our heads around this, we have to talk about what a vacuum actually is. In quantum field theory, the word vacuum doesn't just mean empty space. It actually refers to the absolute lowest possible energy state of a field. But here is the massive catch, and this is crucial. There can be more than one type of lowest state. A false vacuum is essentially a dip in energy that looks perfectly stable, but it isn't actually the absolute bottom. Think of it like a ball sitting in a shallow little dent on the side of a steep mountain. It seems perfectly at rest, totally secure, until it gets just a tiny little quantum nudge and, well, drops even further down the well. Now, this is where it gets kind of terrifying. If we are currently sitting in a false vacuum right now, that means our entire reality, the laws of physics, the masses of particles, the forces holding you together, they're all dictated by a fragile, temporary state. On the flip side, you have the true vacuum. That is the absolute bottom of the energy well. It's incredibly stable, but if our universe were to suddenly drop into it, everything would change. The universe would instantly start operating under completely different physics. So how exactly does this play out as a physical event? Step 1, that little quantum nudge happens, triggering something called tunneling at just a single random point in space. Step 2, a bubble of that true lower energy vacuum suddenly nucleates. It just pops into existence right in the middle of our false vacuum. And step 3, well, step 3 is where things get completely wild. This new bubble starts expanding outwards at nearly the speed of light. Inside this bubble, the laws of physics are entirely alien to us. And the boundary separating the inside from the outside, it's a literal physical wall. It's thinner than an atomic nucleus, but packed with an unimaginable amount of energy. Which brings us to Section 2, the Matryoshka Universe, bubbles within bubbles. If a higher energy vacuum existed before time as we even know it, this actually suggests the Big Bang itself could have been the result of a true vacuum bubble forming about 13.8 billion years ago. If that's the case, the highly energetic wall of that specific bubble wouldn't be something we could just spot in our sky. It would have passed through our region long before light could even travel, placing it way, way out beyond our observable universe. It would literally be the outer edge of our reality. But wait, it goes deeper. Because if our universe is just a bubble, there could be an even lower energy state inside of it, waiting to decay. That would mean, sometime in the future, a second decay could form a new child bubble right inside of ours. It's literally a cascade of nesting universes. It's just like a Russian Matryoshka doll. Every single layer has its own unique physics, its own particles, and maybe even its own bizarre forms of life. But here's the greatest irony of the whole thing. Observers living in every single one of those layers would look around, do their math, measure their physics, and confidently declare that their vacuum is the final stable one. And they would be completely wrong, just as we might be wrong right now. So naturally, this leads to the ultimate question. What actually happens to you, personally, if a child bubble nucleates nearby and its highly energetic wall comes rushing right toward Earth at light speed? Let's break that down in Section 3. When the wall hits, the ultimate rewrite. Okay, if this wall hits you, your atoms are not destroyed in some massive, fiery Hollywood explosion. Forget about Thanos snapping his fingers. This is so much stranger. This is a profound mathematical conversion. Because the vacuum inside that approaching wall obeys entirely different fundamental rules, you are mathematically rewritten. Your protons might literally just dissolve. Your electrons could change into something else entirely. Now, the total energy is strictly conserved. Your mass energy remains, but the specific pattern that made up you is completely instantly gone. The physical structure of you is instantaneously erased. You wouldn't even have time to feel any pain. You would simply cease to be a structured entity, completely rewritten at the most microscopic fundamental level imaginable. Moving on to Section 4, Spacetime and Ultimate Limits, the bottom of the Matryoshka. You might be wondering, does this expanding bubble just magically create brand new space or energy out of thin air? No, it doesn't. What it's actually doing is converting existing space from one phase into another. Let's use an analogy we all know: freezing water. Just as liquid water goes through a phase transition to become a rigid, ordered crystal of ice, some theories suggest spacetime itself is undergoing a phase transition here. A sort of liquid-like quantum geometry crystallizes into the smooth, ordered space we experience today. In this view, our universe is basically just a growing ice crystal in a much larger, supercooled reality. But is there a bottom to this? Does the nesting ever actually stop? Yes, it does. Eventually, you hit what physicists call the global minimum. This is rock bottom, the absolute lowest point of the energy landscape. Once you reach this true vacuum, no further decay is mathematically possible. What's left over in the far, far future of that state is simply empty space-time. No matter, no radiation. Just a vast, unchanging expanse, expanding forever in total silence. All right, let's take a breath and head into Section 5. Beautiful but unproven, the reality check. As your host, I need to impartially share exactly what the source material states here, because this is a vital takeaway from today's explainer. Right now, as we sit here, there is absolutely zero evidence that any of this is actively happening to us. None. Zero. When we actually look out into the observable universe, what we see is a beautifully smooth cosmic microwave background. Lorentz symmetry, which is a foundational pillar of relativity, that basically ensures the laws of physics look the same no matter how fast you're moving. That holds completely true across all of our observations. We haven't detected any giant bubble walls tearing through the cosmos. We haven't found any bizarre space-time crystal lattices. The physical laws we observe appear perfectly unbroken. In fact, there is a fantastic quote from our source material that perfectly sums this up. It says, "It is mathematically consistent, beautiful, and logically possible, but it is not science yet." This concept lives right on the bleeding edge of what we can actually test. If someone tries to tell you they know for an absolute fact that we live inside a decaying vacuum bubble, they're expressing a personal belief for sure, not proven science. So why do physicists even spend time exploring it? Well, because these ideas emerge naturally from thoroughly tested quantum field theories. Exploring these models pushes the very boundaries of what we understand about the ultimate final fate of our universe. To wrap things up today, I want to leave you with a few profound philosophical questions straight from our source material. If we can never actually see the bubble wall coming, is this still a valid scientific idea? I mean, would you even want to know if a bubble wall was approaching Earth, knowing you couldn't do a single thing to stop it? If this Matryoshka doll of universes is infinite, where does the initial energy even come from? And finally, if time continues forever in a completely empty universe at the global minimum, does time still actually pass? I really want you to ponder those. Thank you so much for joining me for today's explainer. Keep wondering, keep questioning, and keep exploring the beautiful, profound edges of our reality. See you next time.